Hello, this is Walter Leite, and in this video, I will show you how to estimate generalized propensity scores for estimating the treatment effect of multiple treatment aversions. This corresponds to chapter 6 of my book, Practical Propensity Score Methods using R. First thing is we'll start with an example using the data from the 1999-2000 School and Staffing Survey. The objective of this example is to estimate the treatment effect of assigning mentors of different areas to new teachers. And the outcome is the probability that you'll continue in the teaching profession in the following year. So we will start with estimating the effect of three different treatment versions. The treatment versions are no mentor, so the teacher received no mentor. The teacher received a mentor of the same area as the teacher, and the teacher received a mentor of a different area. Okay, so the first thing I will do is load the data for my example, which is available in the website practicalpropensityscore.com. And the first step, you estimate the generalized propensity score, is define what covariates you want to use to estimate propensity scores. This covariate should be related to treatment assignment and to the outcome, ideally. So here we have a list of covariates from the School and Staffing Survey that we'll use in this example. So I'm going to create a list. And then I will use a code here to create a formula, which is my model for the generalized propensity scores. Okay, so at the bottom here, we have the treatment assignment model. So the treatment as a function of covariates. Note that the data set had missing data that was imputed. So I also included some indicators here of which cases had data imputed, and I want to try to balance this as well. So for the first propensity score model, I will use multinomial logistic regression model, which is the baseline category logistic model discussed in the Agresti categorical data analysis book from 2002. I'm using the VGAM package to fit this model. So I'll load the package here. And the survey data set has sampling weights. So I'm estimating the model using the sampling weights. Okay, now the family is multinomial, and I declare the data set. So I will fit the model and then take the fitted values, which are the generalized propensity scores. Now I want to have some preliminary idea of common support. I want the distribution of generalized propensity scores to have some overlap. I can do this by just checking descriptive statistics. This is just a very preliminary look. I can see that there is some overlap in the distributions. I don't see any major problems. Now I will, this code here plots a graph that gives me a better look at the distributions. And it saved the graph on the disk. Now, the next step is to estimate generalized propensity scores using boosting. Now, this is an alternative method to the multinomial logistic regression. Here, I'm using the Twang package as the package that will run generalized boosting. And the function for that is MNPS, which is for treatments with multiple versions. One difference here is that with when I did the multinomial logistic regression, the probabilities of treatment for each treatment version, they sum to 1 for a person. Now here, because I'm using a machine learning method, what it's doing is predicting a binary variable that is 1 for a treatment version, 0 for the other. So it's doing it 3 times because I have 3 treatment versions and getting the predicted probability. Therefore, the probabilities will not sum to 1. I'm not going to run this live here because generalized boosting takes a while. And then I save the video. And then I can extract the propensity scores from the object created by the Twang package with this code. And then this requests some plots. And then another method that you can use is the covariate balance and propensity score method, which also, we can do binary treatments and also multinomial treatments and continuous treatments. So this is with the CBPS package. So the strength of the covariate balance and propensity score method is that it tries to estimate the probability of treatment, but also balance covariates. So it's optimizing covariate balance. The generalized boosted with the Twang package also does that. So these are both 2 methods that are not only estimating the probability of treatment, but also trying to optimize covariate balances, which is helpful because our measure of success for a propensity score analysis is whether covariate balance was obtained. Okay, and then at the end here just save the results. So this code gives me 3 sets of generalized propensity scores, which is helpful because I can then use a propensity score method, weighting or weighting is the most common, or marginal mean weighting through stratification, and compare covariate balance across these 3 propensity score estimates that I obtained.